Okay, so this is 1740 here, and we're given this truck, and it has a pipe on the back, and the pipe weighs 180 pounds. I put 180 pounds downward at the center of gravity here of this pipe, and then right in the middle of the pipe. And we're looking to find the maximum acceleration without the normal force at A going to 0. So the normal force at A over here going to 0. So with that being said, actually the maximum acceleration without NA going to 0 is actually, we're going to set this equal to 0, and then that will be right at the tipping point of the normal force going to 0. Okay, so we're actually setting this equal to 0 and solving the problem that way. Right, I've added a few dimensions here to help us out. So the 180 is acting right in the middle of this pole, or this pipe. And so this dimension here is 9.231, and the height from B up is 3.846. So we're trying to find max A, and it also wants us to find Bx and By, the forces the truck is exerting on the pipe at B. Okay, so let's get started with this. And we'll just start by summing the forces in the x direction and setting those equal to the mass times the acceleration of the truck. And I've wrote the acceleration on the truck here as a forward arrow. Okay, so some of the forces in x, we have Bx, and I don't believe we don't have any other forces in the x direction, so that's going to be equal to the mass, which is the total mass of the pipe is, or the weight of the pipe is 180. So we take that divided by 32.2 to find the mass, and then the acceleration of the truck. Can't do anything more with that equation, so let's move on to the sum of the forces in the y direction. And we know it's not accelerating in the y direction, so that is equal to 0. So our forces in the y direction are By. We have negative 180, and those are the only two forces. We know Na is 0 here, so those are the only two forces that we have. That leads to By is equal to 180 pounds. So that's one of the forces the problem was asking us to figure out. All right, so where do we go from here? We have these two equations. This one has two unknowns. We can't go any further. Well, what we can do is take the sum of the moments around B. So the sum of the moments around B over here. And those are equal to the sum of the moments in the kinetic diagram around B. Right? Sum of the moments around B in the kinetic diagram. So the sum of the moments around B, we have the 180 pounds downward here, and that is going to create a clockwise moment around B, so that will be negative 180, and the distance that it acts away is 9.231, and then we have the sum of the moments, kinetic moments, so we have the mass times the acceleration of the truck times the distance that it's acting away. So around B, that distance would be this vertical height here, and that's going to create a clockwise moment around B. So we're doing a clockwise moment, so that will also be negative. I'm going to throw a negative sign out here, and the distance is this distance, this 3.846. Okay, so we know the mass is 180 divided by 32.2. And solving this equation, we have the acceleration of the truck comes out to be 77.3 feet per second squared. Right? And once we have the acceleration of the truck, we can go back and plug it into this equation to find Bx. And let's see, what does Bx come out to be here? Bx comes out to be 432. So Bx comes out to be 432 pounds. And that is problem 1740.